Do you feel the vibes?
Right, so like I said, a rational function will have a variable in the numerator and in the denominator. And to find the domain of rational functions, we have to look at where the denominator equals 0. So you basically take the denominator, set it equal to 0, and those values are going to be your, what is not in your domain. So to find the domain, you have to take the denominator and set it equal to 0 and solve for x. Now, the thing about rational functions is many of them have asymptotes, right? We know what an asymptote is, right? Remember from the tangent graphs? Did we do tangent? So an asymptote is a line that the graph comes exceedingly close to but never touches. And asymptotes can be vertical, horizontal, or actually slanted. So a vertical asymptote is, like this. It looks like this, like that red line. And a vertical asymptote is something that the graph can absolutely never cross. It is like a hard line, like there's nothing can cross it. It's like a force field, there's no crossing. You can come very, very close to it, never touch it, never cross it. Now, a horizontal asymptote is something that looks like this. A function can have one vertical or two vertical or three vertical asymptotes, and it's the same with the horizontal. It can have one or two horizontal. Now, the thing about horizontal asymptotes is it's different from a vertical asymptote in this way. The way a horizontal asymptote is defined is it only takes effect at the infinities. Okay? Which means, even though this graph doesn't show that, but you can potentially have a graph like this, okay, where there is a horizontal asymptote here, okay? The graph is allowed to cross the horizontal asymptote as many times as it wants. So it can, cross as many times as it wants. The stipulation is at the infinities, at the very edges, at the far left and the far right, is when it has to follow the asymptote. You see that? So it's at the edges that the asymptote takes effect. Okay? So don't let that confuse you or whatever. That's just how it's defined. It's at the infinities. All right. Now, how do you find each of these? Okay. This table here is going to be like the go-to law of the land for asymptotes. Right. To find vertical asymptotes, okay, first you have to simplify the function. Then you have to find the zeros of the denominator. So why do we simplify the function? Because if things have to cancel, you cancel them first. Whatever doesn't cancel in the denominator, you set it equal to 0 and you find the vertical asymptote. Right. How about horizontal asymptotes? Horizontal asymptotes are found in a completely different way. For horizontal asymptotes, what you have to do is you have to compare degrees of numerator and denominator. Okay, so there are three situations. Number one, if the numerator has a lower degree, the horizontal asymptote is y equals 0. So like this one, okay? Numerator on top has a lower degree. So look at the degrees here. Over here, I have x to the 2. Over here, I have x to the 3. I can literally ignore everything else in that function. Just look at the highest degree on the top, the highest degree on the bottom. Because it's lower on top, I automatically, with my eyes closed, I'm like, okay, horizontal asymptote is y equals 0. Okay? Because this is lower. Now, what if the numerator and the denominator have the same degree? Like this one. They have the same degree. Now, what you do is you say y equals, and you just take the coefficients, -5/2. Take coefficients of first terms. Okay? And then if you have to reduce, you reduce. Now, the next thing is, if the numerator has a higher degree, no horizontal asymptote. That's it. Okay? Asymptotes are always written as x equals something or y equals something. Okay? Yeah.
So you said that you take the coefficient of the first term. If it's the second term that has
Yeah, like the highest term. So you take the coefficient of the term with the highest exponent, right? Maybe.
So even if the, like, for example, 4x, if 4x had the coefficient, would it be 4 instead?
Yeah, if that had a higher exponent, so like if it was like 4x to the 3. Yeah. So take the coefficient of terms with highest exponents. All right. Find the domain, the vertical and the horizontal asymptotes of the following functions. Okay. So first, domain. Domain is with the numerator. I'm sorry, I said that wrong. We're going to take the denominator. What's the denominator? X squared minus 1 equal to 0. What's x? So this is x minus 1, x plus 1 equal to 0. X equals 1, x equals -1, right? That's where it's 0. So here's what you do. Let's look at this on a number line. So here's -1, and here's 1. At these points, the denominator is 0. So we have to exclude those points. All the other points are okay. So how do we write those regions? This region is from -infinity to -1, right? So I write it like this, -infinity to -1. Okay? Now, union, that symbol means union, so or. The second region is from -1 to 1, or 1 to infinity. So this is my domain. They're like, they look like U's. It's called a union. It means or. So the domain is in the region of this one, or this one, or this one.
Very specific.
Very, like, you think it was like math or something, right?
Mm-hmm.
Yeah. That's why I like math. Yeah, right? Because like we know what we're talking about, right? It's not like ambiguous, wishy-washy. Okay, so we did domain. Let's do vertical asymptote. Again, we take the denominator. X squared minus 1 equal to 0. What did we get for this? X equals -1, x equals +1. These are your vertical asymptotes. You can write it like that, or if you want to save lead, you can say x equals ±1. Okay? If you want full credit, that's what you write. If you don't want full credit and you're fine with just getting partial credit, then you can just say ±1. But that is always half credit, right? Because you don't have the x equals. Okay? All right. Lastly, we want to do what? Which one? Horizontal asymptote. For the horizontal asymptote, we have to compare the exponents, the highest exponents in the top and in the bottom. So here, what's the exponent of the top? 1. And here, 2. So when you have a lower exponent on top, what's the horizontal asymptote? Y equals 0. You don't even need to show work. There is no work to show. All right? Cool, yeah? Yeah. Okay.
That's it?
That's it. Easy as pie. Okay. This one, domain. We take the denominator, set it equal to 0. So this isn't like a perfect square, so we can't factor it. So it's going to be 2x squared equals -1. Take a square root. Oh, no, not take a square root. That's premature. Divide by 2. X squared equals what? -1/2. Take a square root. Now, what happens? Yeah, does that work? Can you have the square root of a negative number? No. Right? That doesn't work. So, what does that mean? There are no real numbers for which the denominator is 0. So remember, our only issue was you can't have the denominator equal 0. Well, this denominator can't equal 0. So there are no issues for the domain. So the domain is all real numbers. Okay? So since there are no real numbers for which denominator equals 0, the domain is all real numbers. So how do we write all real numbers? One way of writing all real numbers is like this. Double bar, and then R from the first bar. Or all real numbers essentially means from -infinity to +infinity, right? So you can also say -infinity to +infinity. So gradually, we're going to go to that other notation. Okay, vertical asymptote. Since the denominator is never 0, none. Okay, for the same reason. Horizontal asymptote. So let's compare degrees. Look, they're the same. Right? So when they're the same, I just say y equals 4/2. Y equals 2. Cool? Yes. Okay, here we go. Domain. What do we set equal to 0? X to the 4. So how much is x equal to? Basically, I take like a 4th root. So 0. So in my number line, x is 0 is where the denominator is 0. Bad things happen there. This region's fine. This region's fine. So how would I write the first region? From what to what? From -infinity to 0. And then 0 to infinity. Yeah. Vertical asymptote, it's where the denominator equals 0. What value is that? 0. It's exactly the same as that. Okay? So it's just x equals 0. Horizontal asymptote. Well, there is one. Because you have lower on top, higher on the bottom, so y equals 0. Okay? Yeah. Okay, fabulous. So let's graph some. Okay, so let's do this one. Before we graph, we want to state the domain and the asymptotes, right? So let's do the same thing. Okay, so domain. X squared minus 4 equals 0. Hey, yes it is. So here's what I want to do. I actually want to factor this here, right? This is x plus 1, and then this actually factors. And then once you factor, it's actually easier. So for the domain, we have problems at -2 and 2. Yeah? So the domain is going to be -infinity to -2, -2 to 2, 2 to infinity. Right? So it helps if you like cross these out and then take all the regions in between. So vertical asymptote. Once you've factored your function, it's actually really easy to find the vertical asymptote because you just take each of these and you just say where each of them equals 0. So from the first one, it'll be x equals what? And the second one? Negative. Oh, shoot. I factored that wrong. It's x plus 2, x minus 2. Sorry. So it's x equals 2 and x equals -2. Right? Or you could do plus or minus 2. Okay, horizontal asymptote. Look at the original function. So this is an exponent of 1, this is an exponent of 2. Where would be the horizontal asymptote? Y equals 0. Okay, so take a look. We have an asymptote at -2, x equals -2, x equals 2. Original, and then y equals 0. Okay, let's get out our calculators. We're going to factor this. I'm sorry, we're going to graph this. Let's go to the graph. We're going to put in, okay, x plus 1 so I put them in parentheses, divided by x squared minus 4. If you're doing it like this, make sure it's in parentheses, because then the calculator will not understand what you're saying. Let's graph. Okay, look at that beautiful graph. Right? Come on, that's gorgeous. Okay, so here's what we're going to do. Now you're going to just transfer this onto your paper. You have to put in like the 0 and the y-intercept. All right, so here we go. We're going to go to menu, analyze graph. I'm sorry, let's go to trace. Menu, 5 for trace, 1 for graph trace. Usually it starts on the the vertical, the y-intercept. So it's 0, -0.25. Let's put that here. Now let's go to the right. I'm sorry, let's go to the left. 1, 2, 3. Let's see. Go slowly. Look at that. You see how it said 0 when I got there? That's at -1, 0.
So where do we write those numbers?
Huh?
You have to know what those numbers are.
Well, we're plotting them, right? Yeah. Okay, so let me go back and trace a little bit more. 5, trace. Okay, so I put, Huh? Oh. So I put 2 in that region, and then let's go back up here. You know, let's just put one more, like negative 2.1 and negative 2.68. And then here, right, look at that, like 2.7, 1.12. Okay, so then what I'm going to do, once I have these points, the important ones are the intercepts. I'm going to draw my graph to match. So you have to follow the asymptotes, right, for the horizontal and for the vertical sides. Do you see how this is a horizontal asymptote, but the graph did cross it because it's allowed to? Okay? So once you do this, you should be able to do this without a calculator. Okay? I want you to plug your functions into the calculator to graph them. All right? Okay, why don't we do the next one? Okay, I want to factor this one. How does this factor? It's x minus 4, x plus 3. This one, if I factor out a 2, x squared minus 4, so it'll be 2, x minus 2, x plus 2. Okay. All right, so denominator is 0 at what 2 points? 2 and negative 2. So the domain is negative infinity to negative 2, negative 2 to 2, 2 to infinity. Okay, what would be the vertical asymptotes? Where does that denominator equal 0? 2 and negative 2. So x equals plus or minus 2. Okay, does it have a horizontal asymptote? Right, you compare the degrees, they're the same. That means I'm going to take the coefficients. 1x squared over 2x squared, y equals a half. Okay, let's put these things here. And then negative 2 and 2. And let's graph. So I'd like to do doc B, just clear everything. I'm going to put in the original, right? So look, you can also do the fraction symbol. That way, when you do that, you don't need the parentheses. So 2x squared minus x minus 12. To go to the bottom, I press tab. Oh, shoot, you're right. 2x squared minus 8. That would have been a completely different. Thank you. Oh, look at how pretty that is, though. Right? We could have never imagined that. Like, plot twist. Oh, I like that even more. Way to go. Okay. That's awesome. Okay, so let's see. So we got to label. Okay, so let's trace menu 5, 1. Okay, so look at that first point, 0, comma 1.5. Okay. Let's go to the left. I'm sorry, I'll go to the right. I want the 0. Oh, there it is. 4, 0.
But then doesn't it cross over to the crossover the 2? Right? Oh wait,
Yeah.
Zero.
So like if you want another point, so like here it's like 0.3, right? It's under the half. Okay, let's go to the other side, the left side. What's the other side? What's the 0? Ooh, for me as well. Yay. Keep pressing left and right arrow buttons. It'll just progress through the graph. It'll cross over. It'll hop over. So now, right, this is going to look like so, right? And again, like you can always put in like more points. I know you guys know how to do that. Okay? Make sure you show like clearly all of these points.
You just want like one of three.
Yeah. Okay. Okay, how about an oblique asymptote? So remember how we said if the denominator has a smaller degree, there are no horizontal asymptotes? If the numerator has a higher degree by 1, then there is an oblique asymptote. Okay? And we find that using synthetic division. Okay? Okay, so let's do this. Does this factor? It doesn't. So, the domain. Where does the denominator equal 0? Just -3. Okay. So all those regions are okay. So -∞ to -3, -3 to infinity. Vertical asymptote, x equals -3, because that's where the denominator equals 0. Horizontal asymptote, none. Okay, but there is an oblique asymptote. Oblique means slanted, okay? Here's how you find the oblique asymptote. You gotta do synthetic division, okay? So in here, I put the coefficients of the numerator. 1, 1, -8. Here, what do I put outside? Right. 1 comes down, -3, -2, 6, -2. That's the remainder. We actually don't care what the remainder is. Throw it away. Now, what do we get here? Y equals what? X minus 2. That's your oblique asymptote.
Why is it -2?
Because like from here, right, it's 1x minus 2. Yeah?
Oh, yeah.
Yeah. Okay, so vertical asymptote, -3.
Why don't we care about
Because the oblique asymptote doesn't care about that. The remainder.
That's just
Because it's this polynomial, that's the oblique asymptote, and the remainder is just, yeah. Okay, so the oblique asymptote is x minus 2. We know how to graph that, right? We go to -2 for the y-intercept, up 1 over 1, and look at that. We get a cute little oblique asymptote, right? Huh? Because slope, right? This is mx plus b. Yeah. So why don't we? Yeah. Oh my God. Like so cool. Yeah. Flashback. I mean, it is Thursday, right? Throwback Thursday to asymptotes and like y equals mx plus b. Okay. Let's graph this person now. Doc B. Let's go here. Okay. What do we have? We have x squared plus x minus 8 That is all wrong. Yeah. X squared plus x minus 8. Why is it doing that? Oh, I see why. Okay, so then here, x plus 3. Oh my God. Gorgeous. Like gorgeous. Okay, let's do this. Oh, that's not what I meant to do. Okay, so menu 5, 1. Okay, 0, negative 2.67. So that's like here. Okay, I don't want to show these here. Okay. Right there. At least like 1 or 2. Yeah. And then here there's like definitely put the intercepts, right? So 2.37 and 0. Okay, my asymptote is not drawn correctly here. And then what's the other 0?
Negative 3.37.
That's right. Okay. Here. Okay. So this is going to look like this. Down. Follow that asymptote. Wait, this one, I have my asymptote in the wrong place. Because they got to be below the asymptote. Yeah, on this thing, it's like, here, I'll do it like this. Because it looks like this. Okay? Okay? Okay, so why don't we stop here today? I do have another day before the quiz next time. But I'll tell you guys what numbers on the homework to do.
Press start.